Hello, this is the video demonstration for the IBM Hack Challenge 2020 by the team Dance with Ensemble. The aim of our project was to create an application that accurately predicts the wind energy forecast for the next 48 hours so that it can help the wind farm owners in determining the best time to operate the turbine so that they can obtain the maximum output energy. That's why the name Winds Dance with Ensemble, aka a driverless wind forecaster. The term driverless because it is automatic and does most of the work without any human intervention, and the name Ensemble because we are using a combination of statistical, machine learning, and deep learning models. That's why the name Ensemble. We were a team of two, myself, Adyansh Bhardwaj, and in this project, I was responsible for creating the Python script. That is, the script which takes the data, performs the computation with the machine learning models, and generates the wind energy forecast. The application was deployed on the IBM cloud by Anand Jakola, and he was also overseeing the backend technologies in this project. So a quick summary of what we are going to show in this video. First, we'll discuss our approach, the existing problem, and our solution that we have deployed. Secondly, we'll show a quick tour of the application's UI, that is, how the application really looks and how it is functioning. And the third one, which is the most important, I guess, what is happening under the hood, that is, how we are really doing the things in the backside. And then we'll have a quick tour of the forecasting script which is written in the Python language. And the final step, which was the deployment, that is how we took all the things and combined them into a single application. And last but not the least, the difficulties, experience, and our learnings from this project. So moving on to our approach part. Generally, for any machine learning problem, the first thing to do is to look into the data and find some kind of patterns or trends that can help in future for predicting the output. But in this competition, we didn't have any data. We only had the problem statement. So I think that figuring out what the data is going to look like was the key questions that answered a lot of things for us. And for getting some more insights, we asked some more questions like what to forecast, who will be using the forecast, what can be its impact, and how much to forecast. So while answering these questions, we reached our first draft of the solution. For the solution part, we have selected the 5 largest wind farms of India and collected data of them. The second step was to select the model or the set of models that can accurately predict the energy of the wind farms. But the key challenge in the wind energy forecasting is the unpredictable behavior of the wind, because wind have different behaviors for different geographical location and time. So selecting the models or the set of models that can accurately predict the behavior of wind is the key challenge in this area. Although we have only focused on the 5 largest wind farms of the India, but we have also provided an on-demand forecast facility for any farm in the world. But for that, we need some hardware-specific details like length of the blade, the power coefficient, and other hardware details. So if those details are made available for us, we can produce a forecast of those wind farms as well. But providing this as a live feature on the application was very much difficult for us because we didn't have the access to those hardware details. So the emphasis was on a stable application. Yes, we wanted high accuracy. We wanted a high accuracy in our application, but we also emphasize on a stable application because, as I said, that the wind energy is highly dependent on the wind, and wind has different behaviors for different geographical locations and time. So we wanted a stable model that can model the wind in every condition. This is a UI demonstration of the app. So this is the app. In the starting, we have placed a small rotating windmill because we thought it will look catchy. So the username for now is root, and the password is also root. And if you want to create an account, then you can click here to join, and it will create an account. So for now, we'll log in. Okay. The first screen after the login asks you how we can help you, and it has 3 choices: the power forecast, that is the location-wise forecast of the 5 largest farms for the next 48 hours. Then the optimum output provides you the best time to extract the energy from those 5 farms. And the power forecast for your farm, that is, if you can provide the hardware specific details like the length of the blade and power coefficient, then we can give you the forecast of your farm. Okay, so let's explore the second option, which is the most intriguing, I guess, the optimum output. Because the fetching of data is in the real time, it might take some time. And okay, here's the output, and as we can see from the graph plotted that the largest amount of energy is produced by the black one, which is the Jaisalmer, and the red one, which is Dalgaon, is also doing good. So this form of plotting the energy into the graph allows us to visualize that which farm is doing great and which farm is having the less output. And when you scroll down, you have the table, which is, I guess, the most important one, and it tells you the best time to extract the data from a particular farm. So for the next 24 hours, the Brahmanville farm has the highest energy output from 4:30 to 5:30 in the morning, and on the next 48 hours, that is the day after tomorrow, the best time to extract energy will be 2:30 to 3:30 in the night. So similarly, for the Dalgaon farm, it's 9:30 to 10:30 in the night, and for the next 48 hours, it is 15:30. That means 3:30 to 4:30. So from this table, we can get the best time to extract the energy. And if you still want a more precise report, then you can click here to view a report, and you can get a precise comparison of different farms. This is the detailed report of the forecast for the 5 different farms, and we can see that the total power generated by the Mopandal farm in the 24 hours is 3041 kilowatt, and in the 48 hours is 809 kilowatt. So it's the power generated by each of the 5 farms for the next 24 and 48 hours is listed, and this is the same graph that we saw on the previous screen. And moving on to the second page of the report, we had the table representation of the energy generated by each of the 5 farms on the hourly basis for the next 24 hours. So we can have a precise value that what will be the energy generated in the next 24 hours by each of the 5 farms. So this is a valuable information. On the third page, we have the power share. It's a pie chart which describes the power share of the 5 different farms. As we can see that for the first 24 hours, the Brahmanville has 29.1% share, and on the next 48 hours, we have also Brahmanville as the largest 32. No, it's Dalgaon 23.9. Okay, so this is the PDF, and if you want to check more, then you can get the complete report. It's 7 to 8 pages large. So the next feature is the power forecast, which is the location-wise forecast for the 5 farms. We have Brahmanville, Dalgaon, Jaisalmer, Mopandal. Let's go and check Brahmanville. Okay, again, it takes time for loading because it's the real-time fetch. It's fetching from the IBM cloud. Okay, so this is the graph of the wind speed. So we can click on the points. It shows that on 2020, 7 July, on 15 July, we had on 3:30, the wind speed was 7.43, and it goes from 15 to straight 17:30, that is the next 48 hours. And below we have a table. Here the today column specifies the value for the next 24 hours, and the tomorrow column specifies the value for the next 48 hours. So let's say for the pressure for the next 24 hours is 961.70 millibars, and for the next 48 hours, the average value of the pressure is 960.61. So this analysis is available for the 5 different pumps. And the last feature, the power forecast for your own farm. If you click it, then it will ask you your email, your state, your city, the number of windmills in your wind farm, the radius of the blade, and the power coefficient. Okay, so let's say we write an email. It's abc@gmail.com. Let it be c9.m, and the state is, let's say, New Delhi, and the city is, let's say, again Delhi. Number of windmills is 100, and radius is, let's say, 80 meters. And let's click on the submit without the power coefficient. And if you submit, it will not accept because we need these specific details. So let's say the power coefficient is 30, and if you provide all the details and if they are valid, it will click submit, and we will get in touch with you as soon as possible, and we'll verify the details. If they are right, then we will be providing the weather forecast. So these are the 3 features available for now for the wind forecast, and we think that if these 3 features can help a lot for any wind farm owner if he or she is planning to obtain the power forecast for the next 48 hours for his or her farm for the extraction of the maximum amount of energy in the least time. This diagram shows the backend of our application. I'll explain with an example. Let's say it's 15 July 11:59 right now, and so the data will contain n-1 days historical data. That means n-1 means 15 minus 1, that is, it contains the data from the past 1 year to 14th July 11:59. So at the moment when the clock hits 12 in the midnight, this application starts running. The Jenkins, which automates the whole process, is the one who runs the first, and it calls the Python forecasting script. The script then asks for the data of n minus 1 days. That is, it's typically 16th on the it's typically 16th July on the clock because midnight has happened. So the data comes into the script, and it is of for it is still the 14th July 11:59. Then it makes a call. Then the Python script makes a call to the WeatherBit API and gets the data of the previous day. That is the 15th July. And inside the computation server, the data, historical data from 14th July and the new data of 15th July gets concatenated, and the new file is then stored into the main database, and the newly generated file is then used for the computation. That is, the machine learning computation is being done by the Python forecasting script on the newly generated data, and the output for the 16th and 17th of July are then stored onto the IBM cloud. Here, the point to note is that the IBM cloud and the computational server are different because the model we are using a combination of different models, and it was difficult. It was not difficult, but impossible for us to implement the combination of such models on a 2 GB RAM, which was provided by IBM Cloud. So we have computed it elsewhere, but the results are at the end stored in the IBM Cloud. So the Flask application, on as per the user request, fetches the data and provides to the user. So this is the overall functioning of the application, that how the application is functioning. And one more important point, the data is also backup. So if in case the, let's say, the database crashes or the API crashes, then we still be having the n minus days data from the day it crashes. So I guess it's the foundation for a stable system, and this image displays how the data is flowing.
So as you have all seen the Android application, I'll be going through the code and the process behind the application. So as you can see, this is the animation we have added. So I've created a flowchart also, so explain you better. Okay. So behind the animation is working on the red or dark screen. Here we can see that the first screen is the splash screen, which is which takes us to the second screen, which is login screen, and the code is on the screens dot sign in dot. This is the code behind the sign in screen. And as we are headed towards password is on okay. So as you can see that we have three options: power forecast, output, and power forecast for your own farm. So when you select the screen from select screen from that file, select screen farm. Okay, this is the first screen. Select power forecast. All the 5 farms are listed here, and included this in select screens. And screens folder is select farm.dart, and this is the code for the same page. Ready for the optimum output. Okay, so similarly for the second output, we'll head towards the all graph output or dart. We are using JSON behind all this process. So this is the code for the same. We have also done the code refactoring so that we can also use the items as well as the data again for some other projects also, as well as we can also scale it up. Uh, for the third screen, as you can see that all the graphs are here as well as the agency are available, and this is the best time for the next 24 hours as well as 48 hours. If I go to the third screen, power forecast. So this screen is for let's say if someone wants to get their personal data for their own farm, which I have not listed here, they can also contact us and we'll give the details to them. Okay, so the screen is future scope. Request your own report. Here's the code for the same. Code has been already uploaded to the GitHub, so you can also go through the code here. And let's say if I submit this, it won't submit because we have already taken care of the, let's say, so that no one can just leave it empty. And for the optimum output, let's say if you click here to view full report, then it will show the full report of the app. This is also being fetched by JSON, which is running on IBM, which is running on Flask and which is running on IBM Cloud. So this is all about the app. We have also included some helper screen. This is all code refactoring, all graphs output table dart. Code refactoring so that will make the code much easier to understand. This is done using classes. Form name, all the forms we have taken from this of one function. And curve painter, as you can see that this section or this curve, which is made by using a quadratic Bezier equation. This is the PDF screen, and we are using a plugin from Flutter, which will help us to present our PDF from directly from the web to our app. And this is of all the graph details. The lines which we are seeing in the app, say the lines which we are seeing in our app is because of this page, which is farm details. You can also zoom in or zoom out to check if it is if we want to compare it. And yeah, line series graph. This is for individual graphs. If I click here to expand, so this is for individual graphs. If you want to see individual graphs, you can also click on the different points to check their date as well as time. Okay, so this is it from my side.